안녕하세요. 한국 사용자 모임의 오신 곳에 신심으로 안녕합니다. This is the Korean I can master. Hopefully you even understood it. But thank you very much for having me to this event. I prepared a video. It's more on the lines of a tutorial, so I don't know if it fits this well to this event. But anyway, here we are. So as always, let's grab your coffee and let's jump right in. But first, let me give you a small introduction. So who is the guy who is talking to you right now? My name is Raphael Rau. I'm a 3D artist based in Ludwigsburg, Germany. And basically I'm known for my photorealism. The funny thing about my scenes is that they're always very small, so basically tiny, because I like those tiny macro details. I usually work with Cinema 4D and Octane, so lately I started a series of dice renders, and especially the second one gathered a lot of attention because it was a rotating dice with refractions and caustics. So I thought, why not do a whole shot for this tutorial, for this event here? So what you're about to see is a dice render from start to finish with modeling and later on a little bit of lighting and then also some volume simulation. So right now, I think we are done with the introduction, so let's actually jump right in. And welcome to this pre-planned modeling session. I made it so it takes the least amount of time to model this thing, so don't worry if you take longer, this is just as efficient as possible. Let's start by creating a Platonic. This is already the shape that we want, so this is great. In order to refine the shape, we have to make it editable. What I want to do is select the points and also select the edges, as we want to perform a edge cut here. Let's hit apply and set the n-gons to all, so we just have the points. This will all make sense later. Hit NB, B for bevel, to bevel the points by 3.5 centimeters, then a extra subdivision here, and last but not least, get the tension to 200. Let's select the middle point of our newly created bevels by going to mesh checking mode, turning it on, going to non-planar polygons, converting it into a point selection and shrink the selection. Here we go. Select those points because they're slightly inset and therefore make those spiked polygons around them not even or not level. So what we need to do is scale them out just a bit, 5% is enough, to make them nice and flush. Next, we need to select those bigger faces that have formed in between the stars, and what better way to do that with the mesh checking again? We can just select the n-gons and be done with that for now. Next, we want to inset those faces, so hit I. We want to go with the standard values, all but the angle. Let's set it to 10 to get all of the face inset. Next, I want to scale all of those faces to a 0 point, and the best tool for this is the normal scale, so let's give it a value of 0 and hit apply. Now, of course, all of the points are living on top of each other. To avoid that, what I want to do is optimize. The next task is to select following edges and dissolve them. Unfortunately, I didn't find a mechanism that lets us do that for the whole object, so we have to go through the process manually on all of the sides. I just turn off the axis here so it doesn't get in our way of selection. Now, while this is running through in time-lapse, just a suggestion for Maxon for the modeling tools, please integrate a select similar feature to avoid stuff like this. Now that we've gone through that, let's actually rotate the Platonic on the p-axis, so one of the tips is pointing up. This will help us with our next task, which is UV unwrapping. Yes, you heard right, we are going to UV unwrap here in Cinema 4D. So what I'm going to do is select some edges here, and as you might have guessed, those will be used to unwrap or unfold the object later. What you can see me doing here is working my way around the object from the tip. And also what you can see, if I go with one swing for the star on one side, I'm going with the opposite swing on the star on the other side. One more to go. And once we've done that, I'm going to find a good place for bridging the top part and the bottom part. The middle part of the dice, so to speak, its belly only needs one cut across, and then from there we can go and follow it to the bottom, where we can then spread out in a star shape again. I don't know about you, but I tried it in another orientation first, and this just broke my brain, so this is why we oriented the object in the first place. Alrighty, once you're finally done selecting, let's get to UV mode to find this scrambled mess. This is the old UV set. To mitigate that, let's go with the frontal projection. go to Relax UVs, turn off Pin Border Points, but turn on Cut Selected Edges, and then we can finally unwrap. Let's straighten the angle by going to the UV Poly tool, select all polys, go to the Rotate mode, and then get it straight as good as possible. To fit it to the canvas, let's go to the UV coordinate section and then use this exact command, fit to UV canvas. Here we go. To actually see what we're doing, let's go to the Textures menu and select the UV map. And you can see the UV map is actually mirrored. And of course, there's a command for this, which is mirror U. And congratulations, you're done unwrapping already. Now, there's one more small tweak I want to make, and this is going to the Transform section and transforming the y-axis by 0.875. This will make sense in a second. Let's first create a texture, deselect the UV map, and then go with File, New Texture, and add it in a lat long format, so it's 2048 by 1024. This means that the proportions now fit again. To make the UVs visible in the texture, let's go to Layer and then Outline Polygons. And last but not least, we can save our file to get access from other software packages. As for example, Illustrator, where we are going to texture this thing. When I first started this project, I didn't even know that our path would lead us through Illustrator and Photoshop. So what we are going to do is use Illustrator to place the numbers you will see on the dice later on. And then after that, we use Photoshop to convert this into pixels. And then we are going to continue on modeling in Cinema 4D. So here we go. Welcome to Illustrator. Let's make a new file, and first of all, we want to make sure it's made out of pixels. And the width is 1000 and the height 500. Last but not least, we want to go with RGB color. Let's drag in the TIFF of the UV map that we just created and fit it to the canvas like this. To make it a little bit more friendly to the eyes, let's go to the appearance and set the opacity to 25%. Then lock the layer, as we don't want to move it accidentally. Next, let's choose the text tool and click in the canvas to bring in some text, and then choose your favorite font. I'm going with Lato, Lato for this project. I'm not sure how it's pronounced. Let's make the text size 60 and type in a 0. What we want to do next is copy the text to the middle of every star-shaped intersection, because this correlates with the space where the numbers are on the dice. And of course, as this is very repetitive, we have a time-lapse again. And then, of course, replace the zeros by the actual numbers on the dice. And if you don't have a dice at hand, you can take this video as a reference. Also note that the second and fourth rows are flipped. As a last thing, so we can read it correctly, let's use the ellipse tool to get a dot on the 6 and the 9, like this. As we are done now, let's turn off our TIFF file helper layer by going to the layer and click on the eyeball. And last but not least, all we have to do is save the Illustrator file. And welcome to Photoshop. Let's drag in our Illustrator file, because we somehow have to get pixels from our vectors. Let's go with 4K, grayscale, and import. As we don't need the transparent background, layer, flatten image, and then Ctrl-I to invert. We are almost done here. The last thing I want to do is blur the image slightly, because we are going to use that as displacement later on, and a blur gives us a nice rounded edge, like this. Then, same as in Illustrator, let's save the result on disk. Back in Cinema 4D, to verify what we did is working, let's just create a standard render material, then drag in the texture into the texture slot of the color. Also, let's go to the Viewport tab, texture preview size, and change that to 2K to get a little bit of a better resolution as we drag it to the object like this. And you can see, yes, this is working perfectly, hooray! Now that we've confirmed that our textures are working, let's continue with a little bit of modeling by adding a bevel deformer. Set the offset to 0.15, and like in the inset deformer, let's go with an angle of 10, and also go with solid mode. And to give us a little bit of a sharper edge, let's make it double and set the offset to 0.05 in this one. Here we go. For better visibility on this object, let's turn off the materials for now and also convert the current state so we have a different object where we don't need the bevels anymore. let's trigger a Phong break selection UN and select it so we have all the edges selected. And what we want to do with this is create a vertex map with 100% density. The next couple of steps are all resided within the select menu, so I'm detaching it here, grow the selection 2 times and shrinking it 1 time, then go to the vertex map, setting it to add and giving it 50% so we get a bit of a better fall off here. This will give us a slight advantage in the shading step later on. For now, what I want to do is rename this object for what it really is, a D20 dice, and finally apply the subdivision surface to it. Here we go. And as you can see, this is evolving really nicely. I hope you like the pace, didn't fall asleep or zone out. So let's continue with shading next. Oh, and one more thing, we didn't care about the scene size until now. So for shading, it's always good to have real-world scale. So what we need to do is get the scale right, and usually those dice are 22 millimeters across. So here we go. While we are at it, let's go to the preferences under units and set it to millimeters so we have a better scene handling experience with those smaller scenes. Hi there, just checking in how you're doing. Hopefully you're fine. I know those rapid fire videos can be a little bit exhausting, so fingers crossed you like it until now, because the rest of the video will go on like this. What we are about to do is go into shading territory into Octane, where we have materials with lots of layers. Also, this is the longest part of the video. So fingers crossed you like it and buckle up, because we're going to go. And welcome to Shading Land. So I provided the scene with some essentials as an HDRI from Maxim Ross, a backdrop, and of course our dice. And this is the dice as we left it off. So first of all, let's create a metallic material for the dice, rename it to D20, and then assign it to the object. Here we go. As you've seen in the beginning of the video, we want to create some light play in the material, so let's bring out a noise into the specular, turn on snapping, and then what we want to do is get a projection going. Set the projection to XYZ to UVW, my favorite, then go with values 0.05, 0.3 and 0.3 on the X, Y and Z axis to make the noise smaller and squish it more together. Then go with an omega of 0.25 to make it less rough, and a contrast of 2 to give it more contrast. And as it looks a little bit boring, let's also add some angles to make it run through the object in a more interesting way. To give this material the Schiller effect, what I want to do is go to the basic tab of the material and then under BSDF go with an energy preserving BSDF and also give it a very high roughness of 0.75. To make the magic happen, what we are going to do is activate the anisotropy with a value of 0.5. And then, to bring this effect home, get the noise out of the specular and into the rotation. So the noise will rotate our anisotropy around and therefore create this interesting Schiller effect where we get a lot of interesting light play all around the object. And of course, you know me, I'm a shading artist, so this is not the end of it. We are going to utilize material layers to go in the deep end of shading here. So let's go to the Material Layer tab, and since you're planning to do multiple layers, let's go with a layer group first. And as a first action, let's actually get another metallic layer, because what we're going to do is some flakes. In Octane, there's a really cool node for that, and you guessed it, it's called flakes. Let's also append a transform to it, because we are going to use it later, and then apply it to the normal of the metallic layer. Per default, the flakes come all in the same big size, so let's vary this a little bit and also change the blend factor so the angle is a little bit more shallow. Still, those flakes are very big, so this is why we have the transform to transform them down to 0.05 to make them sparkly and small. What I want to do also is duplicate the flakes to basically create a mask because we are not seeing the underlying anisotropic material anymore. Also add a gradient to remap those values. To better see what we are doing, let's solo the gradient and go outside of our camera so we can see the object a little bit closer. I bet you can already see the direction this is heading in, so to give us a little bit more wiggle room, what we can do is get the base color to black so we can remap those values even better, like this. And we are almost done with the flakes already. There's 2 more things I want to do. One is to adjust the opacity by giving it a opacity of 75%. And the other is to also give it a GGX energy preserving BSDF and up the roughness to 0.25. Small tip in between, you might have noticed that Octane is creating previews for the material balls as well as the objects in the viewport. This can lead to stuttery node tree editing, so what you can do is disable the OpenGL as well as the material previews. But back to topics, now that the flakes are created, let's create a specular layer as sort of a coating around the object. If you watched my recent Opal tutorial, then you know what's coming. We will create a fall-off map, then steal the gradient here from above, pipe the fall-off through the gradient to the transmission slot of the material, and then solo the fall-off. To get the darker part of the fall-off to the outside of the object, let's invert the minimum and maximum value, and to pronounce it even more, let's get the skew factor to a value of 1. If we look at the gradient, I want to get it back to full range, but instead of a 75% value, I want to go with a blue value here. And if we now disable the solo, you can see the dice in its full glory. Here we go. But of course, as it's tradition right now, we are going to the basic tab of the material, set it to energy preserving GGX and give it a roughness, this time 0.15. But of course, we are still not done. Let's add yet another metallic layer here. With this, I want to pronounce the edges of the dice, so what I want to do is go with a very high roughness value of 0.75. Also, of course, there's the obligatory GGX energy preserving treatment. As for the color, I want to go with a saturated dark blue, like this. As with the flakes, we need some sort of transparency map, and this is where the attribute comes in, as we are going to use our vertex map in there, so we need to set it to float and drag our vertex map in the name slot. And let's turn on solo mode to show if everything's working. It seems like it. Let's again steal the gradient from above and map it in a way so it's black to white, and also a little bit more sharp, so we don't have those fall-offs. So 45 to 55 is a good value range here. And if we go out of solo, we have those nice distinct edges. Really cool. Now, this keeps repeating, but we are still not done. If you noticed, we are still missing our numbers. So what we are going with is a diffuse layer this time. And you probably already know where this is going. Let's bring our numbers as a opacity layer. To save on some VRAM, what we can do is set it from normal to float. The only other thing I want to do to this layer is to make the numbers a little bit darker by going from 70% to 50%. Here we go. You might have noticed that layers in Octane are one attribute only, so this one here is pure diffuse. You can see it best if I move the object so the reflection goes over it. So what we actually have to do is create yet another layer, a specular one, and this is really the last one, I promise, to get the reflection on top of our diffuse. Last but not least, let's give it the old GGX energy preserving treatment and go with a little bit of a higher roughness this time with 0.45. Now, as promised, no more layers, but to get the shader home, we need one more thing, and this is displacement. Let's create a displacement node and also bring back in our numbers. What I want to do with them is actually invert them, because light is always hilltop and black is the valley. Before it refreshes, let's actually get with a smaller value like 0.2 and then also adjust the mid-level so the actual surface of the object is not altered. And of course, to make full use of our 4K texture, let's set it to 4K, and I think I like the height better, a little bit more shallow, 0.075. And to be honest, I think this looks marvelous. And now that we are finally done with the shader, let's take the time and clean up our node tree a little bit. Ta-da! Hey, you made it through the longest part of the video, so there's only 3 sections left. One section about animation, one section about pyrotechnics, and then also one section about shading the pyrotechnics in Octane. So I guess let's keep going. And welcome to Animation Land. So we are going to get a simulation in there, but it would be boring without a moving object. So what we are going to do is animate our object here. We already keyed our frame 0, so let's go to frame 200 and keyframe a rotation with a 360 degree. Right now the animation curve is a Bézier curve, so it starts slowly and ends slowly. I want to change that in a more linear fashion. I do that by selecting the keyframes, unticking auto tangents, and then give the left time a 0 value. And as you can see, this creates a linear curve. So now if you play the animation, it rotates in a constant speed. So good, so boring. To give it a little bit more spice, what we can do is give it a Vibrate tag. Regular pulse is a nice little setting, especially if you want to keep your animation looping. But first, let's actually dial in the values correctly. To get the frequency down, let's go with 0.125. Also, did you know that you can stack Vibrate tags on top of each other so they add to the animation? And this, of course, is what we are doing right now. And as all good things come in threes, let's go with the third one and change it to a rotation instead of a position and slow down the frequency a little bit, like this. First of all, let's create a collider object underneath the dice. So what we need to do is create a cube and then make it a little bit wider and squish it 500, 20, 500. Then set it to -10 so it aligns with the 0 axis. And finally make it a collider by right-clicking on the object, simulation tags, and then collider. Since this is a new category, let's also keep the scene clean. Let's call the cube floor collider, then right-click on the SDS object and then again simulations, but this time Pyro object. And of course also move it into the right category here. Here we go. Let's actually use our default camera to go further away so we can see better what's happening, then press play. And yes, we have ignition. Though to be honest, it's a little bit blobby. To fix this, what we can do is go to our Pyro scene, flap it open, and then change the voxel size to a smaller value. Remember that the dice is also very small, so be careful with small values in other scenes. This looks much more detailed, but also really thick around the object, so what we can do is go to the emitter tag and change the thickness to 1 mm, and this now looks more like what we expect. What we also can do to raise the quality is go back to our Pyro output and then raise the max subdivisions to 50, and if we play again, then it doesn't look as wispy anymore. Very nice. Let's also change that it flows downward. The only thing we have to do is give the temperature buoyancy a negative value for that. And you can see it works. And of course you can also see that the collider is working. If we take a second and look at the running simulation, for my taste it runs really fast, so what I would do is slow it down somehow. And of course I already know the settings for those, so if you go to density and density timescale, let's set it down to 40 and do the same for the temperature timescale. So now if we hit play again, you can clearly see it's slowed down, but the dissipation is also quicker because it doesn't move that far in the same period of time. So what I'm going to do is set the relative density dissipation to 1.5 as well as the relative temperature dissipation. And if we hit play now, you can see now the fluid lasts a lot longer. And we are almost done with the simulation. What I want to do is give it a pre-run of 75 frames, so set the scene time to -75 here. So it's already settled in the scene time we start the rendering. And as a last thing to do is to cache it out to disk. The good thing is that Cinema 4D saves out VDBs, so what we can do as Octane users is go and use the volume object in the VDB mode. All we need to do is navigate to the folder that Cinema 4D cached the VDB files in, select the 0 frame here, then hit calculate. 0 to 200 is correct. And last but not least, I don't know why this is, set the import unit to decameters. And this brings us to our last section already. Depending on how you're feeling, this is already or it took ages. So depending on you, hopefully it's already. So what we have here is the volumes and we're going to shade them in Octane and give them a very magical feeling as you've seen in the beginning of the video. So let's get going and jump right in. Let's make this all work out back in Octane. So first of all, what we can do is make the collider object invisible. Let's also turn off Pyro and the Pyro emitter. Let's make this work in Octane by going to the Octane volume object, go to the medium tab and click fog. And you can already see the slightest bit of fog. So let's go inside of the medium and change the density. So to 1000 for example, or to 5000. So whenever you change the density and not much is happening, the volume step percent is at the wrong scale. For me, it was a value of 10. Now, what we also can see is that the dice is misaligned, and this is because we are starting from minus 75 instead of 0. If we move the playhead to 0, then everything is fine and dandy again. Let's get back into the volume shader and tweak the other values a little bit, for example the absorption. Let's make this value a bit higher so we get a little bit more of a fluffy feeling. To get the fog looking more magical, what we can do is use a volume ramp inside of our scattering. The default gradient makes stuff just look less dense, but what we can do is flap this open and load a preset like this one here. It's just important that the leftmost knot is black. And if we now map the max value to the right range, we get this magical rainbow fog. Let's actually bring this project home by going with a density of 500 here in the smoke, then go back to our render camera, and also what's missing is a light. So let's add a light source. First of all, let's make it a little bit smaller, 100 by 100 millimeters, then add a null object as a center, then move the light down the z-axis minus 1000 units. Now we can rotate the light around the center null, for example to the right with 80 degrees and slightly up with minus 45 degrees. Go to the Octane light settings and change the power to 1 and also tick off surface brightness. Right now the HDRI is also really bright, so let's set its power down to 0.1. And now if we toggle on and off our light, you can see its power and its distribution. Speaking of distribution, let's make this light a spotlight with a spotlight distribution. Let's disable the active preview, go into the distribution slot and actually change the cone angle to 15. In terms of look, let's give the scene the right oomph by adding the one-click ACES solution here. This makes it really dark, so to counter that, let's give it an exposure of 1.5. And of course, as the last good deed for the day, what we need to do is clean up our scene, name our objects, and get everything tidied up. Whew, that was a really fast-paced video. I think the fastest-paced video I've ever made. Hopefully you came out of it with more knowledge, more inspiration, and not too exhausted. Of course, as this video had to pack in a lot in 30 minutes, I glossed over a lot of things, but you get the chance to look at the original scene file that I used for the preview, as you can simply download it with the QR code on screen right now. So in the original file I used much more detailed materials as I had longer to grade them. Also I did use particles in the air as well as on the objects themselves. Well, as there are only two objects, mainly the floor. Anyway, let's give it back to myself for the famous last words. And this is already it. Thank you very much for having me. I hope you liked the presentation. Many of nights went into that. So I say 감사합니다. Hopefully that was pronounced correctly. And have a good evening. Bye.